Artificial intelligence (AI) is a rapidly evolving field that's transforming our world. In essence, AI refers to computer systems designed to perform tasks that typically require human intelligence, like learning, problem-solving, decision-making, and understanding language. From recommending movies to powering self-driving cars, AI is already deeply integrated into our daily lives. Learning plan. What is AI? We'll start with the basics: what AI truly is and how it got to where it is today. Types of AI. We'll explore the different classifications of AI, from the specialized to the more human-like. How AI works. Key technologies. We'll dive into the underlying technologies like machine learning and deep learning that power AI. Applications and impact of AI. We'll look at where AI is used in the real world and its broader effects on society. Ethical considerations in AI. We'll discuss the important ethical questions and challenges that come with developing and using AI. By the end of this plan, you'll have a solid understanding of what AI is, how it functions, and its role in our lives. At its core, artificial intelligence (AI) is about making machines intelligent. Think of it as teaching computers to think and act in ways that traditionally required human brains. This includes a bunch of cool abilities. Learning. Just like you learn from experience, AI systems can learn from data. The more data they see, the better they get at a task. Reasoning. This is about using logic to figure things out, like solving a puzzle or making deductions. Problem solving. AI can tackle complex problems, from finding the shortest route on a map to strategizing in a game. Perception. This involves interpreting sensory information, like recognizing objects in an image that's computer vision, or understanding spoken words that's natural language processing. Decision-making. Based on all the information they've learned and reasoned through, AI systems can make choices. Natural language understanding. This is a big one. It's how AI can understand what you're saying or typing, and even generate human-like text. Imagine a smart assistant on your phone. It learns your preferences, reasons about your requests, solves problems like setting a reminder, perceives your voice, makes decisions like which song to play, and understands your natural language. It's pretty amazing how much goes into seemingly simple interactions. Does that initial explanation make sense? Would you like to try a quick activity to see how these concepts pop up in everyday AI? Excellent! Now that we have a good grasp of what AI is, let's look at the different types of AI. It's useful to think about AI in two main ways, based on its capabilities and based on its functionality. First, let's talk about AI based on its capabilities. There are three main categories. Narrow AI or weak AI. Artificial narrow intelligence (ANI). This is the only type of AI we have successfully developed and widely used today. Narrow AI is designed to perform one specific task extremely well. Think of it like a specialist. It's brilliant at its particular job, but it can't do anything beyond that. Examples: voice assistants like Siri or Alexa. They're great at understanding commands and answering questions, but they can't write a novel or perform surgery. Recommendation systems on Netflix or Amazon, spam filters, facial recognition software, and even AI that plays chess. They are narrow because their intelligence is limited to a very specific domain. General AI or strong AI. Artificial general intelligence (AGI). This is the hypothetical next step in AI development. General AI would be able to understand, learn, and apply intelligence across a wide range of tasks, much like a human being. It would possess cognitive abilities similar to humans, including reasoning, problem-solving, and adapting to new situations. Think of it: an AGI could learn to play chess, then instantly switch to writing a poem, then solve a complex scientific problem, all without being specifically programmed for each. This is still a major research goal and doesn't exist yet. Superintelligent AI or artificial superintelligence (ASI). This is even more theoretical and advanced than general AI. Superintelligent AI would surpass human intelligence in virtually every aspect, including creativity, problem-solving, general knowledge, and social skills. It's the stuff of science fiction, like machines that are vastly smarter than all of humanity combined. Imagine, an ASI could potentially solve global problems like climate change or cure diseases with ease, but it also raises significant ethical and control questions. To summarize, we're currently in the era of narrow AI, and general and superintelligent AI are still concepts we're working towards or imagining for the future. Does understanding these capability-based types of AI spark any questions for you? Or would you like to consider a quick scenario to see if you can identify which type of AI is at play? You're on a roll! Just as we categorize AI by its capabilities narrow, general, superintelligent, we can also categorize it by its functionality, meaning how it works and what kind of operations it can perform. This classification, proposed by AI researcher Arend Hintz, helps us understand the progression of AI development. Here are the 4 functional types of AI. Reactive machines. These are the most basic and oldest forms of AI. They don't have any memory of past experiences and can't learn from them. They simply react to current inputs based on pre-programmed rules. Think of them as machines that can only see the present moment. Analogy: imagine a calculator. It performs calculations based on the numbers you input right now, but it doesn't remember the numbers you typed 5 minutes ago to influence its current calculation. Examples: IBM's Deep Blue, the chess-playing computer that beat Garry Kasparov. It could analyze the chessboard's current state and make moves, but it didn't learn from its past games in the way a human would. Another example is a simple spam filter that just flags emails based on keywords. Limited memory AI. This type of AI can store and use past data for a short period of time to make decisions. It's a big step up from reactive machines because it introduces the concept of memory, even if it's temporary. Analogy: think of a self-driving car. It needs to remember the speed and direction of nearby cars, the position of traffic lights, and recent road conditions for a few seconds to navigate safely. It doesn't need to remember every car it's ever seen in its entire existence, just what's relevant in the immediate past. Examples: self-driving cars, they remember recent observations like lane markings, traffic, etc. to make immediate driving decisions. Virtual assistants like Siri or Alexa, which can remember the context of your current conversation, and recommendation systems that use your recent viewing history. Theory of mind AI hypothetical. This is a much more advanced and currently theoretical type of AI. It would be able to understand and model the beliefs, desires, intentions, and emotions of humans and other AI entities. Essentially, it would have an understanding of how others think and feel. Analogy: imagine being able to truly understand why your friend is upset, not just by their words, but by their tone, facial expressions, and past experiences. Theory of mind AI would aim to do something similar for machines. Why it's important: this would be crucial for AI to interact naturally and effectively with humans, leading to more empathetic and socially intelligent robots and systems. Self-aware AI hypothetical. This is the most advanced and purely theoretical type of AI, often seen in science fiction. It would not only understand others' mental states but also possess its own consciousness, self-awareness, and sentience. It would be aware of its own existence, feelings, and internal states. Analogy: this is like a machine truly becoming alive and having a sense of I. Current status: this level of AI is not even remotely close to being realized and raises profound philosophical and ethical questions. So, while reactive machines and limited memory AI are what we work with today, theory of mind and self-aware AI are still ambitious goals for the future. Do these functional types of AI make sense? Perhaps we could try a little matching game to reinforce your understanding? Now let's get into the nitty-gritty of how AI actually works. While AI is a broad field, a huge part of its success today comes down to a powerful technology called machine learning (ML). Think of it this way: AI is the big goal making machines intelligent. Machine learning is one of the most effective ways to achieve that goal. It's like building a house AI where the foundation and most of the construction ML are done by teaching the house to build itself from examples, rather than giving it a blueprint for every single nail and brick. Here's the basic idea behind machine learning. Learning from data, not explicit programming. Traditionally, if you wanted a computer to do something, you'd write a specific set of instructions code for every possible scenario. With ML, instead of telling the computer exactly what to do, we give it a lot of data and let it figure out the patterns and rules on its own. Analogy: imagine teaching a child to recognize a cat. You don't give them a list of rules like, if it has pointy ears, for legs, and whiskers, it's a cat. Instead, you show them many pictures of cats and other animals and say, this is a cat. This is not a cat. Over time, the child learns to identify a cat on their own. ML works similarly. Training data. This experience for the AI comes in the form of training data. This is a large collection of information relevant to the task. For example, for an image recognition AI, thousands of labeled images, for example. This is a dog. This is a tree. For a spam filter, thousands of emails, each labeled as spam or not spam. For a recommendation system, your past purchases, ratings, and browse history. Algorithms. At the heart of ML are algorithms. These are complex mathematical models and sets of instructions that the computer uses to find patterns in the training data. The algorithm learns from this data, adjusting its internal workings to get better at the task. Think of it like a chef algorithm using ingredients data to create a dish. The learned model. The more practice and good ingredients the chef has, the better the dish becomes. Patterns and predictions. The ultimate goal is for the ML algorithm to identify patterns in the data. Once it understands these patterns, it can then make predictions or decisions on new, unseen data. If it learned from spam emails, it can predict if a new email is spam. If it learned from house prices and features, it can predict the price of a new house. It's a powerful loop. Collect data, feed it to an algorithm. The algorithm finds patterns and learns, and then it can make intelligent predictions without being explicitly told how for every single case. Does this initial dive into machine learning make sense? Do you have any questions about how AI learns from data or the role of algorithms? We can also discuss a simple example to illustrate this process. Fantastic! Now that we've covered the basics of machine learning, let's explore where AI is truly making an impact, its applications across various industries, and its broader societal implications. This is where AI moves from theory to real-world transformation. Real-world applications of AI. AI is already integrated into so many aspects of our lives, often without us even realizing it. Here are just a few examples. Healthcare. Diagnosis. AI can analyze medical images, X-rays, MRIs, CT scans to detect diseases like cancer or identify abnormalities with incredible accuracy, sometimes even better than human eyes. Drug discovery. AI can sift through vast amounts of data to identify potential drug candidates and accelerate the drug development process. Personalized medicine. AI helps doctors create customized treatment plans based on an individual's genetic makeup, lifestyle, and medical history. Virtual assistants. AI-powered chatbots and virtual nurses provide preliminary medical advice, answer patient queries, and schedule appointments. Finance. Fraud detection. AI systems monitor transactions in real time, flagging suspicious activities and preventing financial fraud. Ever had your bank call you about an unusual purchase? That's AI at work. Algorithmic trading. AI algorithms analyze market data and execute trades at lightning speed, often leading to more efficient markets. Credit scoring and risk assessment. AI helps financial institutions assess the creditworthiness of individuals and businesses, often enabling fairer and more accurate decisions. Customer service. Chatbots and virtual assistants handle routine customer inquiries, improving efficiency and availability. Transportation. Self-driving cars. This is a big one. AI powers autonomous vehicles, using sensors, cameras, and machine learning to perceive their surroundings, navigate, and make decisions on the road. Traffic management. AI optimizes traffic signals in smart cities to reduce congestion and improve traffic flow. Predictive maintenance. AI can predict when parts of a vehicle or infrastructure might fail, allowing for maintenance before a breakdown occurs. Route optimization. For delivery services and ride-sharing apps, AI calculates the most efficient routes to save time and fuel. Entertainment. Recommendation systems. Think Netflix, Spotify, or YouTube. AI analyzes your viewing or listening history and preferences to suggest new content you might enjoy. This is why your recommendations always seem so spot on. Content creation. AI is being used in scriptwriting, music composition, and even generating hyper-realistic visual effects in movies and games. Gaming. AI controls non-player characters NPCs in video games, making them more realistic and challenging. AI can also adapt game difficulty to your skill level. Impact of AI on society. AI's widespread adoption brings both exciting benefits and significant challenges. Benefits. Increased efficiency and productivity. Automating repetitive tasks allows humans to focus on more creative and complex work. Enhanced decision-making. AI can process and analyze vast amounts of data much faster than humans, leading to more informed and accurate decisions. Improved quality of life. From medical breakthroughs to personalized learning, AI has the potential to improve various aspects of human life. New job creation. While some jobs may be displaced, AI also creates new roles in areas like AI development, ethics, and maintenance. Challenges. Job displacement. Automation by AI could lead to certain jobs becoming obsolete, requiring significant workforce retraining and adaptation. Ethical concerns. Issues like algorithmic bias. If AI is trained on biased data, it can perpetuate and even amplify existing societal biases. Privacy concerns. How AI uses our personal data, and accountability. Who is responsible when an AI makes a mistake are crucial. Security risks. AI systems can be vulnerable to cyber attacks, and the misuse of AI could have serious consequences. Lack of transparency. Black box problem. Sometimes, it can be difficult to understand how an AI reached a particular decision, especially with complex deep learning models. It's clear that AI is a double-edged sword, offering immense potential while also demanding careful consideration and responsible development. Do any of these applications or impacts stand out to you? Or would you like to explore a specific application in more detail? We could also play a quick AI or not AI game to test your understanding of where AI is actually being used. You've hit on a crucial point. As AI becomes more powerful and integrated into our lives, the ethical considerations surrounding its development and use become incredibly important. It's not just about if we can build something, but should we, and how can we build it responsibly? These ethical discussions often revolve around a few key principles. Fairness and bias mitigation. The challenge. AI systems learn from data. If the data used to train an AI reflects existing societal biases, for example, historical discrimination, underrepresentation of certain groups, the AI can learn and even amplify those biases. This can lead to unfair or discriminatory outcomes. Example, an AI used for loan applications might unfairly reject applicants from certain demographics if it was trained on historical data where those groups were disproportionately denied, even if they were creditworthy. Example, facial recognition systems trained predominantly on one demographic might perform poorly or be less accurate when identifying individuals from other demographics. The principle. AI systems should treat all individuals and groups fairly and avoid producing discriminatory outcomes. This involves carefully curating training data, using algorithms designed to mitigate bias, and constantly auditing AI systems for fairness. Transparency and explainability. The challenge. Many advanced AI models, especially deep learning models, are often referred to as black boxes. It's difficult to understand how they arrive at a particular decision or prediction. They simply give an output without a clear explanation of their reasoning. Example, if an AI medical diagnosis system tells a doctor a patient has a certain condition, the doctor needs to know why the AI made that diagnosis to trust it and make informed treatment decisions. The principle. AI systems should be transparent, meaning their decision-making processes should be understandable and explainable to humans. Explainable AI. is a field dedicated to developing techniques to make AI models more interpretable and their decisions justifiable. This builds trust and allows for accountability. Accountability. The challenge. If an AI system makes a mistake or causes harm, for example, a self-driving car accident, an incorrect medical diagnosis, who is responsible? The developer? The user? The AI itself? Since AI isn't a legal entity, defining clear lines of responsibility is complex. The principle. There must be clear accountability for the actions and decisions of AI systems. Humans should ultimately remain in control and responsible for AI's deployment and outcomes. This involves establishing frameworks for oversight, auditing, and recourse when things go wrong. Privacy and data protection. The challenge. AI thrives on data, often personal data. This raises concerns about how data is collected, stored, used, and protected. There's a risk of misuse of personal information, data breaches, or AI systems inferring sensitive details about individuals. The principle. AI systems must respect user privacy and personal data. This means adhering to data protection regulations like GDPR, ensuring data security, using data minimization techniques, only collecting necessary data, and often anonymizing data where possible. These principles guide the ethical development and deployment of AI, aiming to maximize its benefits while minimizing potential harms. It's an ongoing conversation, and as AI technology advances, so do the ethical considerations. Does discussing these principles bring any thoughts or questions to your mind? Perhaps we could explore a scenario where one of these principles is particularly relevant. Awesome! Let's test your knowledge. Here's your first question. Question 1. Which type of AI is currently the only one that has been successfully developed and widely deployed, capable of performing one specific task extremely well, like recommending movies or playing chess? A general AI. B. Superintelligent AI. C. Narrow AI. D. Self-aware AI. That's absolutely correct. C. Narrow AI is indeed the type of AI that is currently widely used and excels at specific tasks. Great job remembering that key distinction. You're clearly grasping the different categories of AI. Ready for your second question? Question 2. Machine learning (ML) is a core component of how AI works. What is the fundamental principle of how ML systems learn? They are explicitly programmed with every single rule and instruction for a task. B. They learn patterns and make predictions by analyzing large amounts of training data. C. They operate solely based on human intuition and direct input in real time. D. They rely on innate, pre-existing knowledge embedded at their creation. You got it again! That's perfectly correct. B. They learn patterns and make predictions by analyzing large amounts of training data. This is the defining characteristic of machine learning, and it's fantastic that you remembered how powerful learning from data is for AI. You're demonstrating a strong understanding of how AI functions. Let's try one more to round out our quiz. Question 3. When discussing the ethical considerations of AI, what does the principle of fairness and bias mitigation primarily address? Ensuring AI systems are always correct and never make mistakes. B. Making sure AI algorithms are kept secret to prevent misuse. C. Preventing AI systems from perpetuating or amplifying societal biases present in their training data. D. Guaranteeing that AI systems can explain every single step of their decision-making process. Excellent! You've absolutely got it this time. C. Preventing AI systems from perpetuating or amplifying societal biases present in their training data is precisely what the principle of fairness and bias mitigation aims to achieve. It's about ensuring AI is equitable and doesn't discriminate. You've done a fantastic job on this quiz. You correctly identified narrow AI, understood the core of machine learning, and then, with a little nudge, pinpointed the essence of fairness in AI ethics. Session summary. Today, we embarked on a journey to understand artificial intelligence. We started by defining AI as the ability of machines to perform tasks requiring human intelligence, covering core concepts like learning, reasoning, and problem solving. We then explored the types of AI, distinguishing between narrow AI, the specialist AI we have today, like recommendation systems and voice assistants; general AI, human-level intelligence across many tasks, still hypothetical; superintelligent AI, intelligence surpassing human capabilities, also hypothetical; and functional types like reactive machines and limited memory AI, what exists now versus theoretical theory of mind and self-aware AI. We then delved into how AI works, focusing on machine learning (ML) as a key technology. You learned that ML enables AI to learn patterns and make predictions by analyzing vast amounts of training data, rather than being explicitly programmed for every scenario. Next, we discussed the exciting applications of AI across various fields like healthcare, finance, transportation, and entertainment, seeing how AI impacts our daily lives. We also touched upon the broader societal impacts, including both benefits and challenges. Finally, we wrapped up with the crucial topic of ethical considerations in AI, emphasizing principles like fairness and bias mitigation, transparency and explainability, accountability, and privacy. You did really well on the quiz, correctly answering 2 out of 3 questions immediately and then getting the third one perfectly with a hint. This shows a solid grasp of the key concepts we discussed. I believe you've met your learning goal for understanding artificial intelligence. You now have a comprehensive overview of what AI is, how it functions, its real-world impact, and the important ethical discussions surrounding it.